Today we're going to take a look at a practice set that's going to simplify using I. We're also going to solve equations that may contain I in the final answer. As a reminder, I is just the concept of the square root of a negative 1. Really the idea is that it is the only number that you've ever seen before. It is the only number that when you square it is still negative. Because remember, the concept of square rooting and squaring will undo one another. They're inverse operations. So if you squared this square root here, you would just be left with a negative number. So the idea of I is that it's a number that when you square it, it is still negative, which you've never had up to this point. So when we're going through and simplifying, we can really just treat I, kind of treat it like a variable when we're trying to combine these numbers. This is referred to as just a complex number. It's got, notice how it has like a real part here. By real, I mean it doesn't have the I on it. And the imaginary part, like the 5i, what we're going to do is we're going to add up these two pieces, but we're just going to add up the real parts together, and then we're going to add up the imaginary parts together. So when you do that, you really treat I like a variable in terms of combining like terms. So notice how there's addition in between these two. What if when there's addition, I don't really even need those parentheses there. So for some of us, it might be beneficial to just get rid of the parentheses so that you can see a little bit more clearly that that just becomes 1, and this here becomes minus 7i. And that would be your simplified form. For number 2, we're trying to simplify square roots. So the first thing we need to do is break it apart to this. 40 times negative 1. Now, the square root of 40 can get broken down further, but the square root of negative 1 is I, so we can rewrite it like that, with the I outside, not underneath, outside of the radical symbol. But now we have to take it a step further, and we need to break apart the number 40. So we use our perfect squares, 4, 9, 16, 25, 36, and we try to break apart the number 40. So just going to the next step, that's equivalent to 4 times 10. Don't forget about the I. Square root each of those numbers on the inside, and you get a 2 square root 10i. That is its reduced version. I know it doesn't really look like it's reduced because there's more going on, but you took out the negative, the imaginary part. You broke apart the 40 into two smaller numbers that can be square rooted. Now, you don't ever have to show this step, just so you know. Okay? If you want to just right away go to this, great. Just take out the I, take out the negative, which is a square root of negative 1, and then you could just continue through the process. Okay, the next one is subtraction problem. So when you have a subtraction problem, you have to remember you are subtracting this whole entire right side. So if I'm just going to rewrite it, I don't need the parentheses for the first set. But here, I'm subtracting 9 and also subtracting 3i. So now we can combine negative 4. We can combine these, negative 5i. And that's as far as you can go. The next one here, though, notice it's a product. Distribution is what we're going to have to do. So multiply each of these in. 3 times negative 4 is negative 12. There we go. 3 times 2i is 6i. And then plus 8i. And then negative 2i times 2i multiplied by is negative 4. But then careful, I times I squared. So let's combine this here. Negative 12, those two go together. 14i minus 4i squared. If you get to the test, this will be marked wrong, okay? Yes, you combined it, and this one has an I and I squared and a constant. And there's nothing we can technically combine right now, but what you have to use is this right here. The idea that when you square I, it is equivalent to negative 1. So technically, you have negative 4i squared is saying negative 4 times negative 1, which is just a positive 4. So I could rewrite this and say 14i plus 4. Well, now I can combine those two, and my final answer, -8 plus 14i. So that's what we get there when simplifying. Okay, so you can never have an I squared in your final answer. Last two here. These are saying, let's just try to solve them using any of the techniques we've learned so far. Square rooting, graphing is just using our graphical approach of like x-intercepts, or the quadratic formula, and or factoring we could do as well. But let's see what we have here. First one, there's a single x. When there is a single x, that means it is perfect for trying to square root. That is like your go-to technique if you only see one x in the problem. Here, two of them. Can't square root it. Not going to happen. So what can I do? Algebraically, start moving things to the other side. Move that 27 by adding it. Move that 3 by dividing it. I have what's being squared. Square root it. Don't forget your plus or minus. And then x minus 1 equals plus or minus 3. Move the 1 to the other side by adding it. But here's the thing. It does not become, when you add 1, it does not become plus or minus 4. That's where you got to be careful. It becomes plus or minus 3 plus 1. So how do you interpret that? 3 plus 1, -3 plus 1. So my two answers, 4, -2. So those would be our two solutions to number 5. Graphically, if this was a y in front right there, and then we plugged a 0 in, those are our x-intercepts if we were to look at the graph of this function. Number 6, we could try to factor it, or we could use quadratic formula. Factoring though, here's the issue. I would need to find two numbers that multiply to 9 and add to 3. No numbers work. There's not a set of numbers that would work in this situation, so we know we cannot factor. So I have to apply quadratic formula. X equals -b plus or minus square root b squared, which is 9, minus 4 times a, which is 1, times c, which is 9, all divided by 2 times a, which is 2 times 1. Now we got to do some simplifying. You always simplify this first. So you simplify, making that picture a little bit larger, simplify first. So 9 minus 4 times 1 times 9. So what does that say? -3 plus or minus 9 minus 4, 1, 9, 36. All divided by 2. Keep on going. -3. Square root of -9 and 36, -27 over 2. Keep on simplifying. -3, let's take out that imaginary part, that square root of -1. That's where the I comes in. So our solutions are going to be imaginary, not like they don't exist. It's just using that number I. That's what we refer to when we say imaginary. All divided by 2. And then finally, simplify your square root even further, right? So I can take that 27 and I can break it up to 9 times 3, square root the 9, and a 3 comes out. The square root of 3 stays. The I is still there, and there's a 2 on the bottom. Now, when you look at this answer, there is a lot going on. You don't have to go any further, though, in terms of breaking this up, because you've got the square root and the I. You can't get down to whole numbers like we did here. So -3 plus this and -3 minus this would be your two solutions. That's it for simplifying and solving when I shows up in your equations.